Okay, ladies and gents, let's start today. Today is actually nothing much news, it's just the continuum from yesterday. Okay, yesterday we talked about the concept of the support already, but we haven't actually talked about connection yet. Okay, today will be similar, however I will add in one more support. Okay, plus two connections. Okay, before we begin, because as I said there's nothing new here, so I will start off with handing out the sheet. So while we try to understand what is going on in the solving problem, you can see how the forces come into it. Okay. Okay, well, when you're ready. That is just as I said, nothing new, so I'm not going to go too much in details, okay? But just go straight to the topic, right? These are one more support. On the first row is what we call fixed or cramped roller supports, okay? The condition of the picture is that this member could slide up down the slope, but cannot move 90 degrees to outside or toward the slope. Okay? Plus, that point there is not allowed to rotate. Meaning, if it beginning at that angle, it will always begin in that, it's gonna remain in that angle. Right? Notice the angle between the member and the floor. That angle has to stay. Okay, basically it cannot rotate. As a result, like always, one force 90 degrees to the floor against the motion, and then of course the moment stopping it from rotating. Okay, that is the end of the support so far. We can have more support later. Okay, now the next thing we talk about is the connection. Notice that this is not a support though, right? This is not support. It is just two members connecting. That little circle there signifies what they call pin joint, meaning it joining via pin. Okay, pin in Thai is like KMUTT, right? Notice if you put in a pin on something, it cannot move at all, but it can rotate around the pin, right? This is the same type of connection, meaning these two members cannot be separated. That member and that member has to be attached here. If it's separate, then it's break. Okay? However, it can rotate around each other. Okay? Therefore, the reaction between the two, then only two forces 90 degrees to one another, no moment. Okay? Meaning if you try to pull it apart, that member will be pushed out by that member and that member pushed back. Right? If you try to slide it up and down, right? To resist it, one will be pulled up, one will be pulled down to resist the motion. Okay, but no moment resistance. That one is called, oh sorry, that is my mistake. Could you change that word? It's not support, it's connection. My apology. Okay, mistype. Basically, again, this is the kind of connection. This is a strange one. It's usually connected to a pipe that can slide like that. Okay? And then it's up down to the clamp thing. Basically you can slide up down the rod, the shaft, right? But you cannot rotate, you cannot pull it apart this way. Therefore, this one is the force that stops it from moving 90 degrees to that connection. Okay? The flow of that connection, and it cannot rotate, therefore the moment acting between them. This picture, although looks strange, is kind of intentional, strangely enough. Let me ask you this. This force and this force, it is against one another, correct? This moment and this moment, is it the same direction or is it against each other? Meaning, do they go together or do they go against each other? That moment and that moment. Basically, if one going clockwise, the other has to go anti-clockwise, correct? Again, action and reaction. On the left hand side picture, the body on the left hand side, it goes clockwise. On the right hand side, it's go anti-clockwise. It's actually going against each other. Okay? Again, I said, this is really rely on what we learned yesterday, right? On condition. This is a new type. It's a new symbol. Do you have to remember them? Apparently you do. This is almost like hieroglyphics. It's a language in itself. Language by picture. Okay, when you draw this picture, people in the field understand what you mean by that picture. Okay? Get used to it. It's just six of them so far. Okay? Let's see example. Similar to last time. A bit more horrible. No. There are two parts of it. From A to B and from B to C. These two parts was connected by the pin joint. We just saw, right? On one side is support by fixed support, on the other end is the roller. Okay? Then the first thing first, if we consider the free body diagram, something a little bit annoying happened. Well, the idea is to find all the forces, reactions and the member. Right? I'm not going to slow motion this time. If I'm concerned you are very good at it already from yesterday's practice. That is a fixed support, right, by the picture. Fixed support has three reactions, two forces, one moment. There. Two forces, one moment. Right? That is called roller. Right? One force, 90 degrees to the floor. There. One force, 90 degrees to the floor. Direction is guessing. We don't actually know if whether it's up or it's down. Right? If it actually up, it will become positive when we calculate it. If it actually down, it becomes negative. If it's positive, it is assuming correctly. If it's negative, then we're guessing wrong way. Okay? What is the first problem? How many equations do you have? No. How many equations? 3. How many unknowns? 4. So that's your first problem. Okay? Now, apparently there's a point where we know that it's a special case. Apparently that about point B, by the condition, is actually have no moment applied on it. It cannot be moment inside because it can rotate. Right? So the idea is that we're just going to split up at the connection. Okay? So we redraw the free body diagram. This time I will draw from A to B on one picture and one from B to C on another picture. Okay? Then we will have two free body diagrams, not one, two of them. Okay? The first three reactions from the fixed support is still here. Okay? That one happened because the contact here between the two parts, that contact is contact by pin joint. Pin joint said you have two force 90 degrees to one another. So these are the two force inside the pin joint. Okay? Then that is one picture. That one there, then B to C is that picture. That reaction comes from that support. Okay? That two again, action and reaction with these two inside the pin joint. Okay? This time you have three equilibrium conditions from A to B. You have another three from B to C. In all you have 6 equations. Correct? The unknown is 3 here, 2 here become 5. These two and these two are the same, we already count. Therefore that's another 1, 6. So now we have equal equations and unknowns, simultaneous equation. Well, we don't have to go 6 equations, 6 unknowns, okay? We just solve it one by one. Okay? By this picture, we know that this picture we have 3 equations, but we have 5 unknowns. Maybe we should start here. Right? This picture we have 3 equations, we have 3 unknowns. Right? So we start here better. Okay? Then, as I said, we start here from B to C. Sigma fx 0, bx 0. Right? Then sigma moment about point C here. Then you have RBY into that equation. We know how to set it up already. Now, the question is, where is the distributed force from A to B? Remember, when we do free body diagram, we only care about forces and moment acting on the body, right? Those forces here. This side here is here. Now we are looking at that body, so that force is not acting on BC, right? So we just ignore it. We only care what is acting on BC, okay? When we calculate this part, then we don't care about this either, okay? There we go. Sigma Fx, then sigma moment about point C, okay? 20 times 2 total force times the distance 1, okay? That the arm RBY 2, okay? Therefore, there we go, we have RBY, and then of course we shall have RCY as well. Taking moment again about point C, okay? You can use sigma Fy as well, okay? But you are usually using sigma Fy for check. Okay, I think the problem is that I changed the question, and I haven't actually changed my calculation yet. Okay, sorry for that. But all force, the two forces go up 30 and 30, 60. Total force coming down 30 times 2, 60. Sigma Fy will become 0, right? Okay. Once we work out RBY and RBX, then we can update that free body diagram. RBX 0, so we just ignore it. Okay. Notice that there is a little problem here. That is RBY, right? But this picture we said RBY go up. Okay. But in this picture, as we said, it is action and reaction to each other. So this one RBY correctly go down, right? So when the force actually happens inside the material, the symbol will be different. Okay. At this, hello. Okay. At this point in time, I rather you guys, if it inside the connection, like the pin joint, like the clamp roller, just ignore the direction for now. Okay, only the reaction at the support for now. Okay, so then we go 3 unknowns, 3 equations. We go to the same thing. Sigma Fx equals 0. Then sigma, well, this is 1 by 1. X1 unknown, Y1 unknown, right? Just go 1 by 1. Then become, yeah, correct, sorry. I'm getting paranoid now. Right, so, okay, and then we have RAY, take moment about point A, then we have also MA. Okay? Is that confusing or is it okay? So, whether it's hard or not, it's not really hard. It's just, rather than solving 3 equations, you get the answer. Now you have to solve 6 equations, that's all. Okay? Fun, right? We like calculating, come on. We hope. Let's look at another example, okay? Oh, hang on, let's summarize the answer first. The first set, we actually calculate from this picture. Oh, we haven't changed it yet. Since we are at it, notice one thing. When you have one answer wrong, the following answers will be wrong. Okay? So when you make the first calculation wrong, the rest will not be counted. So be really careful. It's like a chain reaction per se. The calculation orders is not, actually naturally it's not left to right. It's not up down. Okay? You consider it, which one you go first. In this one, we go from the 3 unknowns picture first. Right? That one. Okay? Once we know all the forces on the right hand side, then we know RBX, we know RBY, and therefore we move on to calculate on the left hand side. Okay? Just to remind you what we have done in order, I've just put in the number for it. Okay? And summarize, that is summarize of the step of calculation, the way we look at it. And then that one is summarize of the answer. Move on to the next one. Hopefully I don't make mistake this time. This one here has connection here, right? With the new connection we just learned, and a new kind of support we learned today as well. Again, this picture doesn't mean much apart from it supply different kind of forces. Okay, so go on with the same thing. If we look at the free body diagram, the first goal, we draw the whole thing. Then we will have again 4 unknowns, right? We can go to the same system, split up to calculate one and the other. But this time we'll try something new, okay? I bring up this one, but then I will draw from here to here, okay? Meaning I'm not drawing from there to there, from B to D anymore. I will solve from A to B and use information of that one to calculate the whole picture here. Okay? The choice is yours. You could do either way. Okay? So, if you're going to do that one, let's ignore the top one first, the big one first. Do that one first. Then 3 unknowns. Sigma fx, one of them. Sigma fy, one of them. Might as well go x, y, z then. Okay, x, y moment per se. Right? Sigma fx equals 0. Simply rbx becomes 0. Right? Sigma fy, therefore that picture, just the force coming down 30 span 3. Right? One distributed force coming down, one reaction going up. Therefore it has to cancel out. Ray therefore 90. Upwards. Then of course the moment, take moment about point A. Why do I take moment about point A? Can you guess? If I take moment about point B, then I have to take about this force and that force and the moment. Right? I will have 3 terms. I'm too lazy, so I take moment about the virus, about here. Meaning there are 2 terms only that I have to think of. One is that distributed load and one is that the moment. Right? Therefore in my calculation I only have 2 terms. Okay? If you take moment about this point, will you have the same answers? Yes, you will. You can try it. Okay? But you will have 3 terms in the equation, that's all. Move on. Then I will have the value of MB. Again, because MB has a pair. If this one going anti-clockwise, on the right hand side, if you go clockwise against one another, this is inside the connection. Therefore, I will leave it out for now. We will talk about the symbol of the forces inside material in the later stage, meaning after the midterm examination. Okay, that's more advanced knowledge then. We will get there, I hope. Okay? Then once I know this information, when I apply back to the picture, I actually need only RAY, right? Because then I will use this picture. RAY was 90 upwards, right? So I will solve the picture and ignore that one because I did not split the member. There is no environment here. It is just one body still. Okay? The only thing I take out from this picture is the support, right? So what happened? We see the forces acting between the support into the body, not between the body, because I did not cut the body off. It is the same piece still, right? Therefore, there is only one force applied here, 90, and I left with 3 unknowns still. Again, look at it, sigma fx, sigma fy, sigma moment should go one by one, right? So we take those equations. Sigma fx, then rdx still 0, right? Sigma fy, then that one go up, that one come down 6.5 meters, right? Times 30. Then rcy go up, that is the one we don't know, right? Then we move the equation around to solve it, that is the value of rcy. 180, yeah. Okay. Then taking moment, again, this time I take moment about either point A or maybe point C to eliminate one term. I can take moment about here too, get the same answer. Okay? Therefore, in fact, this one I should take moment about point C, but never mind, already take moment about point A. Okay? But I know RC, so then we have that term doesn't count, times 0. That is 1 term, 2 term, and then the moment. That's 1 term from the distributed load. That is another term from RCY. and that is the moment doesn't have any distance, right? Then from the equation you can solve for RD, not RA, sorry, not MD, not MA, MD, sorry. Okay, that is MD. Now notice that it starts with minus. Okay, then we have to change it into plus before you answer. Okay, so add in another line, give it a plus value and then tell directions. This one I assume clockwise. Minus mean it go against what I assume, then it become anti-clockwise instead. Okay, and that's it. And then that's summary of the answer. But this time I answer MD. It has to be totally separated, two bodies. Oh guys, let's have a little break. Okay, I will call for a break for 10 minutes. You can back in 10 minutes. I will go prepare something else and come back. Okay. Ladies and gentlemen, the time is already up now. So, thank you very much, and I see you guys again next week. Thank you.